This video shows the oxidization of ultra-fine particles of iron by solid state of carbon dioxide. A solid state of iron and gas state of carbon dioxide does not react. The iron atom in a metal is hard to cause reactions owing to the metallic bond. However, oxidation of ultra-fine particle of iron by solid state of carbon dioxide can be confirmed by the change of color on particles that turns from black to reddish color. We can see the smoke as an accompanying phenomena. Here, the oxidation of iron by carbon dioxide is exothermic reaction. On the other hand, the iron oxide reduction is an endothermic reaction. The motivation on the research of oxidation of ultra-fine iron particles by dry ice. Adjacent atoms in a living body are replaced frequently by thermal motion. The life of creature is maintained by the exchanging appropriate atoms for the changing situations. By neighboring contact of the giant molecules, the iron atom can be exchanged with carbon atom of carbon dioxide. The barrier energy for the replacement of atoms is not so high. The chemical reactions by exchange of atoms between adjacent giant molecules was confirmed by the experiment. The experiment to confirm that the fine powder of iron is oxidized by dry ice was carried out. At first, fine iron powders shown in the photo and powder of dry ice are put into a glass bottle, mixing the powders evenly. After that, the bottle is closed by the cap. Put the bottle into the big jar that is filled with dry ice. The big jar is closed by a big cap and it's stored in a freezer. Take out the jar after 29 hours from the freezer. Then, compare the processed powders with initial powders. The photograph shows the results of the first experiment. On the right side of each photo is black. The black powder were oxidized by dry ice. Only small iron particles were reacted with dry ice and turned to 3,4 iron oxides. What will happen at the ultra-fine iron powder on dry ice? The next experiment is the oxidation of ultra-fine iron powder by dry ice. Ultra-fine iron powders are made by heating oxalic acid iron, as shown in right photo. Spontaneous combustion of the iron powder that is made from oxalic acid iron takes place by exposure into the air. Magnesium burns, gaining momentum in the boiling water or in the atmosphere of carbon dioxide. That is, H2O and CO2 have the function of oxidizing agent. There are reactions accompanied with heating of iron oxalate. The iron oxalate is decomposed into iron, carbon dioxide and water by heating at about 200 centigrade. The decompositions of iron oxalate includes ferrous oxide. But the ferrous oxide is unstable at low temperature below 573 centigrade. It turns to iron and ferric oxide through slow cooling down. The decompositions of iron oxalate may include carbon monoxide. But the carbon monoxide is unstable at low temperature. Almost all carbon monoxide turns to carbon dioxide at temperature below 400 centigrade. The processes to get ultra-fine iron powders from iron oxalate are as follows. Heats the iron oxalate by heating bottom of the test tube with shaking. The color of iron oxalate will change from yellow into black by the heating. If the black powder lost fluidity, stop the heating and immediately seal the test tube. After that, the powder is cooled down slowly. The time axis of slow motion replay is expanding to twice times, because the ultra-fine iron particles change in a short time. We can see that particles change the color from black to red, and the reaction produces smoke. We can see that particles change the color from black to red, and the reaction produces smoke. A flame of gas igniter was moved into inside of the bowl in order to check existence of carbon dioxide gas. After sublimation of dry ice, the iron powders burns by an approach of a flame. It produces a red ferric iron oxide. Reaction of fine particles were represented by slow motion replay. Smoke is generated through the oxidation of fine particles of iron. We can see often the reddish smoke. But our eyes cannot see the reaction of the ultra-fine particles well, because the reaction time of the particle is short. This movie was photographed at the microscope mode. Since the particles overchanges in a short period of time, this video is replaying with a slow motion of 8 times stretched. The process that causes the smoke by sewing the ultra-fine iron powder on dry ice is as follows. Oxidation of ultra-fine iron powder on the dry ice heats the material. Carbon dioxide of the dry ice evaporates by the heat of oxidation. The fine iron particles will flow together with the vapor of carbon dioxide. This is zoom-in images to see floating fine particles. Conclusions. There are the chemical reactions by exchange of atoms. The carbon atom of dry ice can be exchanged by iron atom of ultra-fine iron particle at the neighboring contact. The energy barrier of exchange of atom is smaller than the energy of excitation to isolate an atom. The reaction by the replacement of the atoms of adjacent substances will be the mechanism of metabolism on a creature. Thank you for your kind attention.